Hello friends, in this video lecture we are going to talk about converting a number from standard form to decimal and vice versa. This concept is very important for science students, those doing physics, and chemistry students, and even for mathematics and further mathematics students, so that whenever you are having your answer in standard form, you can easily convert that answer to decimal form and vice versa. That means you can also convert from decimal form back to standard form. So this is something that you should know how to do accurately so as to avoid picking the wrong answer from your options during your JAMB or your WAEC or your school exams. So how is it done? We are going to use an illustration for this, which you have to keep in your mind. It's not too big stuff to keep in your mind, so you can just keep it in your mind. Two arrows, one pointing to the right and the other pointing to the left. So that's the illustration we're going to use. There are two cases involved here. The first case is when you're converting from standard form to decimal, and the second case is when you are converting from decimal to standard form. So for these two cases, we are going to use the same arrows for the illustration. You just have to keep it in your mind. So once you remember the direction the arrow is pointing towards and the sign attached to it, you will know how to move your points. So first of all, what is a standard form? A standard form of a number is the form of a number written as this: a times 10 raised to the power of n. So whenever you have a number written in this form, the number is said to be in standard form. Example, 25 times 10 raised to the power of 3. This is a standard form of a number. Then for the decimal form, whenever you have a number written just as a whole number, or a whole number having a decimal point with other digits coming afterwards, that is the decimal form of a number. Example, 25. 25 can also be called a decimal form of a number. Why? Because it's assumed that we could also put a point here and then a zero comes afterwards, and it's still approximately 25. So that is why a whole number can also be said to be a number in decimal form. But actually, numbers in decimal form should actually have decimal points. To have decimal points. So when you are converting from a decimal form to standard form, or from standard form to decimal form, we have to make use of carefully understood methods to do it so that you get your answer accurately. So let's take them one after the other. The first case will be converting from decimal to standard form. That will be the first case we're going to take, converting from decimal to standard form. In this case, you're drawing the arrows in your mind, and on the top of the arrow pointing to the right, you have a negative sign, and at the top of the arrow pointing to the left, you have a positive sign. Why are we putting signs? The signs are there to show us the direction to which we have to move the point. The direction which we have to move the point. That is where the sign is actually there. Now, given a number such as 25.000, 25.000. Now, if you are to convert this number to standard form, this is a decimal form, converting it to a standard form, you have to know what direction do I move the point, and that will tell me the sign that will be in my standard form. Is it going to be a negative sign that will be there, or a positive sign? Because back to our standard format, you can see this n always takes a sign. this n always takes a sign. It's either the sign attached to it is positive or negative. Now, for you to know the sign that will be attached to that n, it depends on the direction to which you have moved your decimal point. The direction which you have moved your decimal point. And you can't move your decimal point unless you actually know where your decimal point ought to be. That is where your decimal point should actually what? Be. Where your decimal point ought to be here. Okay, now this is quite this can be quite confusing or technical. Okay, now let me explain it in a better way so as to avoid future confusions. Now, your decimal point actually can be anywhere. Your decimal point can be here, it can be here, it can even be here. So your decimal point, it can be here, it can be anywhere. Okay, but now actually where your decimal point will always be for a given number. For example, you are given a number like this, 500. Your decimal point, if you're asked to pick out where your decimal point is, of course it's coming after the last digit. Yes, your decimal point actually ought to come after the what? Last digit. But for major forms of conversions which are usually done when converting from decimal to standard form, they will most time prefer to put the decimal point at this point. That was the reason why I was actually saying that is where your decimal point ought to be, but it's not the standard. It's not the standard. So they will likely love to prefer it to be at that point for the purpose of simplicity of your answer. Yes, simplicity of your answer. Yes. Okay. Now, but if you are to move it to any other point, you are still free, but it must reflect in your standard form. How do I mean? What I mean by that is the sign shows you the sign is a result of the direction. The sign is a result of the direction, but the value is a result of the movement. The value is a result of the what? Of the movement. That is number of movements. The number of what? Of movements. That is what tells us the value that will be in your standard form. If the answer is going to be 2.5 times 10 raised to power 1 times 10 to the power 1, or 2500 times 10 raised to the power minus 2. So here you can see we have two values. The first value here is minus 2, and this is what? Plus 1. So we are having 2 and 1. So why the difference in value? 2, 1. Why the difference in value? That's because of the number of times we move the point. But why the difference in sign? Here we have positive sign, and here we have negative sign. Why the difference in sign? That is because of the direction to which we moved the point. Because of the direction to which we move the points. So let's take a proper look at this question and let's answer it. So let's convert 25.000 to a number in standard form. Now we want to put the decimal point right here at this point. We want decimal point to be there. So for a decimal point to go there, it means we have to move it from where it is originally to that point by how many times? 1. And are we moving to the left? Yes. Since we are moving to the left, it means that the sign will be positive. How many times did we move? We moved once. So it means we're going to have a positive 1 attached to that 10, which will be in our standard form. So the standard form now is going to be 2.5, because this is actually where we are trying to bring the point to come after 2. So we can have 2.5, and then every other number that comes after 5 can be discarded. Can be what? Discarded. So 2.5 times 10, which is a standard, raised to the power of what? Positive 1. And this is the standard form of that number. Yes, which could also be written as 2.5 times 10 raised to the power 1. Okay, now what if we want to move the decimal point somewhere to a point somewhere here? So we can be having 0.25. So if we are to have 0.25, look at it carefully. It means that we are going to move the point like this. I'm going to move the point like this, 1 and 2 times from where it was originally. Now, to what direction do we move it? We moved it to the what? Left, meaning we're going to have a positive once again. How many times did we move it? We moved it twice, 1, 2. So it means we're going to have a positive 2. So we are going to write it now as 0.25. Other numbers can be discarded. Other numbers can be discarded, especially when they are all zeros. 0.25 times 10 raised to the power of what? Positive 2. Or simply 2. You can just write it as raised to the power of 2. You know, a positive sign is attached to 2 already. So that's how to convert from decimal to standard form. Now the points can be anywhere. You could even decide to decide to place the point. You could even go further. You could go further like this and just keep on going further, or you could decide to move to the right and just like that. But you must know that the direction which you are moving the points to is what determines the sign that will be attached to this index, and the number of times you moved it is what will determine the value of the index. So you must always keep this illustration in your mind, because this is what will tell you the sign that will be attached to each direction. The sign to be attached to the direction when you are going to the right, that is towards the right, is negative, and the sign that should be attached to the direction of the left is what? Positive. That's what that illustration helps you to remember, and with more practice you don't have to take much time to remember that. You just store it up in your mind that to the right negative, to the left positive. That's when you are going to standard form. Now what if you are going from standard form standard form to decimal? Standard form to decimal. So here we are going to have the same illustration, but this time around is the reverse or the opposite. To the right becomes positive and to the left becomes negative. Now if you are given a number such as this, 25 times 10 raised to power minus 3, this is a standard form of a number. Standard form. You are converting this standard form to decimal. This is even quite simpler. All you have to do is to come and take a look at the index. What sign is attached to the index? The sign attached to the index is negative. That means you are to move the point to the left while bringing it back to decimal. Just move the point to the left. By how many times? 3 times, because the value is 3. So very simple. So this means our answer is now before we write our answer, you have to know where is the point originally. Like I said before, if you're having a whole number like this, the point comes after the last digit. So the point is here. You can't say the point is here. No, because you were not told that. Since you are not given any position of the point, so the point comes after the last digit. All right. Now let's move the point and get our answer. So for us to do that, our answer becomes, we are moving the point from this place to the left by 3 times. 1, 2, 3. The point stays here. Yes, and just below this empty space, just below this empty space, we're going to fill it with a 0. So for every empty curve you're having, you put a 0 under. Just like here we're having 2 under the curve, 5 under the curve. Here, every empty curve takes a 0. That means our final answer becomes 0. There is no 0. There is no 0 here actually, but since it's empty, it's a 0 that will be there. So the answer becomes 0.025, and this becomes the decimal form of the number. 0.025, that becomes the decimal form of the number. Hope that's clear. So this is how you can convert your numbers from standard form to decimal, and from decimal form to standard form. So I'm going to give you some questions for you to attempt, and you just practice them so that you can get used to it. So question 1, you're going to convert 0.00089 to standard form. Then question 2, I'm going to convert 13.000 to standard form. And then question 3, I'm going to convert 284.000 to standard form. So that's for the conversion from decimal to standard form. So the next assignment will be conversion from standard form to decimal. So standard form to decimal. So question 1 is going to be convert 128 times 10 raised to the power 5 to decimal. Question 2, convert 22.46 times 10 raised to the power minus 3 to decimal. Question 3, convert 25 times 10 raised to the power 5 to decimal. So all you have to do is to keep the illustration in your mind. Just keep the illustration in your mind. This is for standard form to decimal. This the arrows and the sign, and this is from decimal to standard form, the arrows and the sign. So once you keep that in your mind, practice a lot. Just practice a lot of questions with this. Give yourself questions so that you can get used to it, and you discover that you will be more confident when you are doing your conversions. You won't be asking yourself again, am I right? Are you sure I'm not making a mistake? Am I right? And you're very sure that your answer is going to be correct. Stay blessed. Remember, Jesus loves you.